All right, and so today we're going to talk about similar figures. And what do we know? We're going to first find the value of x, and they are similar figures. We went over the definition of similar today. What do we know? If I have similar figures, I know two things. I know, Cammie. Yes, so you're going to write these notes on your paper. Similar figures means two things. One, it means that the side lengths are proportional. And so we're building on that idea of proportional that we used last week.
It's also that one word.
It's also that one word. What else do we know? If it's proportional, what's congruent?
They're the same. They're equal.
What things are congruent?
Angles.
Good, thank you. The angles are congruent. And I love that some of you remember that definition from last year. Congruent means that they are what? The same. The idea of proportional is what we're going to focus on today. What questions do you have so far? So they're telling us, and we're going to do number 2 together, that these two figures are similar. Yes, I know. We have to use what we know about corresponding sides, the one that are in this relative same location, the ones that kind of match up. What two side lengths do we know in these two triangles that correspond to each other? What two side lengths correspond? Someone raise your hand. Tell me which ones correspond. For number 2. Yep, we're doing number 2 together. Which ones correspond? Caden. M and N. So this longest side length, and which one? You're absolutely right. How do you know, Caden, that those two correspond? Yes, I love how he described that. They're both the longest side. Because I promise tomorrow some of them are going to get flipped around. So you have to compare the relative size. So it's not always the one on the top. It's because they match up according to this is the longest and that's the longest.
So wait, so how do you find it?
And so because MN and PQ are both the longest sides, they correspond. We don't have enough information yet.
Oh.
We just know those two things correspond. What else do we know though? We know, Gracie, what? Yes, how come 9 meters and 3 meters correspond to each other? You're right. Tell me why, Hannah. Ooh, that's not why they correspond. Well, that's a true math fact. That's not why they correspond. Why, Ryan? That is not why they correspond. Why do 3 and 9 correspond, Cooper? They're both the smallest. They're both the smallest. So, bless you. Now, we know we're comparing side lengths and that similar figures are proportional. How do we make up a proportion? Tell me how I make this proportional. What do you think?
Oh, I had it in my head. Proportional. Like, don't you switch something?
Rach?
3 times 3 equals 9.
Oh, now I love you found this relationship right here.
It's proportional.
3 times 3 is 9. And so, yep, but we weren't there yet. So how do I figure out what x is?
3 over 1 equals 9 over x.
I'm sorry. Someone raise your hand and tell me, because I've heard three different responses. Eric? So I could do 7 times 3 is 21 meters. I always want you to look for that first. I always want you to say, wow, if I can go from one corresponding side to another one with a whole number, I might as well just multiply. Okay? That 3 is called the scale factor, what I would multiply by. Okay? Sometimes, though, you don't know. Sometimes you don't know that whole number. So how would I set up the proportion? How do I make my proportion What over what equals what over what? What do you think, based on what I know, corresponds? Give me your best guess. Rach?
3 over 7?
Now,
21.
we're going to pretend we don't know 21.
So that's the answer.
Because that's the answer.
So it equals
Right.
21 over 7?
Not here. Nope.
Well,
So what two sides?
3 over 1 is equal to 9 over 1, but that's
That's not right, right? So what you just said is not. Gracie, what do you think?
not correct.
Shh.
3 over 9.
Now, it for sure could be 3 over 9.
Or,
That means you're putting the small one over the big one. I'm going to tell you, I had one group this morning put the big one on the small one. Okay? Does it matter?
no.
As long as you're consistent, it doesn't matter. Where does the 7 go then? Does it go on the top or the bottom? And why? If we put the small one on top of the big one, where does the 7 go? On the top or the bottom, Cooper? Why? Is this the big shape or the little shape?
The little.
Is this the big shape or the little shape? So does it go on the top or the bottom? Goes on the top. Good.
And the 21 goes on the
And then the X goes here,
Oh,
right?
and that's 21.
Now, I could cross multiply. 9 times 7 is 63 and divide by 3 to get 21. If I cross multiply, which always works, you're still going to get the same answer. We're always going to try to be efficient, though, first. Okay? Do you have to know how to set up the proportion? You know I'm going to ask you some that are fractions and decimals. You know I am, right? 7th grade numbers. So, do you understand how we did that?
Yeah.
Cooper?
You know how you're recording yourself?
Yes.